Hello everyone and welcome to Applications Manager's free training series. Thank you all for taking your time out and being here today. So let me walk you through the agenda for today's session. We have 4 parts for today. In part 1, we'll be looking at how you can auto-discover components and dependencies across your entire application stack. In part 2, we'll be looking at how you can measure key performance metrics across your application infrastructure. In part 3, we'll be looking at how you can utilize AI and ML to detect anomalies, analyze performance trends, and plan capacity. And finally, in part 4, we'll be looking at how you can leverage the most out of Applications Manager's integrations. Moving on, we'll start with part 1, which is auto-discovering components and dependencies across your entire application stack. So imagine your gym. Jim is an IT admin in a growing organization. So the organization or the company is expanding its digital services, deploying new applications, microservices, and cloud instances rapidly. However, you or Jim have no clear visibility into what's running inside your environment. So every time an issue arises, whether it's a slow application or an overload server or an unknown dependency, it takes hours or even days to manually map out the affected components. The lack of visibility leads to delayed troubleshooting, performance bottlenecks, and worst of all, downtime that impacts end users. The first step to gain app-centric visibility into your IT infrastructure involves analyzing your infrastructure. So as you can see, this would be your infrastructure. This is a basic diagram of your infrastructure, and this can help you understand what exists in the infrastructure and what needs to be improved and what changes can be brought upon. So let's look at the challenges that we face in this particular section. So the challenges is mainly since the IT teams rely on manual tracking of application servers and dependencies, it becomes unmanageable as environments grow, especially in multi and hybrid cloud environments. So you have a lack of visibility into the IT infrastructure. And then you have potential security risks due to undocumented applications and services. So this is basically shadow IT, where undocumented applications and services can cause or introduce security risks and compliance violations. When a performance issue or outage occurs, IT teams struggle to pinpoint the root cause due to a lack of clear dependency map. So manual investigation takes hours or even days, increasing the mean time to resolution, which will frustrate the end users. And without proper discovery, IT teams may allocate resources inefficiently, which leads to underutilized or over-provisioned servers and cloud instances. So coming back to this particular scenario with Jim, so here they lack the necessary visibility to pinpoint the source of the problem, whether it originated from the database or a specific server or another unforeseen component within the application stack. They often suspect that database might be the culprit, but due to limited visibility, they couldn't determine the location of these database servers, and pinpointing the root cause becomes a time-consuming struggle. Additionally, identifying slow-running queries within the database proves equally challenging. So we needed a solution, as in the company needs a solution to gain deeper visibility into the complex IT infrastructure and proactively manage the applications. So that is where Applications Manager, with its comprehensive application performance monitoring and infrastructure monitoring capabilities, emerges as the perfect solution. So here, as you can see, with a single click, Applications Manager can discover the servers, services, applications, and all the other infrastructure elements that are present within your IT environment immediately. And to discover these resources across the IT infrastructure, 3 methods are used. One is the network discovery, the second one is the bulk discovery, and third one is the virtual infrastructure discovery. So the network discovery is basically the process of discovering all the resources in a specified network. It discovers the monitors running in the default port only. And in bulk discovery, We can use a bulk import option to add the monitors of the same type in bulk. Bulk import of monitors is performed by using a CSV file, which contains all the configuration details of the monitors you wish to add. And so ideally there are like two types of dependency mapping that is done in Applications Manager. One is the server to application dependencies, which displays all the applications that are running on a server and maps the applications that are interconnected with each other. And the second one is the application to application dependency mapping, which displays the applications that are running on the same and different servers and maps the ones that are interconnected. So our application discovery and dependency mapping feature helps you discover and group the resources, establish relationships between them, map them correctly to provide a holistic view of your IT infrastructure, assess the health and impact of the potential resources, and more. For example, if an application is running on server A, using the database which is running on server B, so for these two servers, we can create a relationship map. We can also view the live status of the applications at the hosted servers as well. This feature will help you detect and isolate problems, if any, to obtain the periodic status of your applications and make informed decisions. Rather than checking if the host server is down or the database is down manually, you can check this view to pinpoint the exact root cause of the issue. So what are the benefits of application dependency? So you get a business view of all the discovered applications. Like I mentioned, you get the server to server mapping based on the connected applications. You also get to see the live status of operational devices. You can identify down applications faster, and you can get the root cause diagnosis for quicker troubleshooting. So let me show you how it looks in the UI. So this is the ManageEngine's user interface. Here, you go to settings, and under settings, you have add or discover under discovery and data. So here you can add a new monitor. As you can see, we support monitoring for more than 150 technologies, be it application performance monitoring, cloud apps, converged infrastructure, database servers, mail servers, middleware and portal, servers, virtualization, or web servers. Okay, as you can see, you can just click on any one of these technologies to add a monitor. So, but if you want to bulk import the monitors, you go to bulk import here. Choose the monitor type. So, for example, I'm going to choose Amazon. Choose the file. And click on next. So here, when you choose the file with the necessary header with the display name, everything, it would be added immediately. As for discovery, we have three types of discovery. One is the network discovery, dependency network discovery, virtual infrastructure discovery, and bulk discovery. So here in the network discovery, just go to add new discovery. Here you can type out the details here. For example, and click on the subnet mask. Which kind of subnet mask you want? Click on next. So here you can see the servers, applications, and all the IT infrastructure elements that are present within that particular network. On next, and here you will be able to add your credentials. If there are any available credentials that are already found in your system, you can just add that credential to the IT infrastructure elements that you've just discovered. If not, we can just add a credential here. Then click on next. So here you can schedule the discovery, whether whether you need it daily, weekly, or monthly, and you can either scan and add all the IT infrastructure elements here, and click on discover. So when you click on discover, it will start discovering the servers and all the other applications in your network. And here you can see the dependency mapping. So to add the dependency map, you have all the monitors that are already present here. Just click on the monitors that you want to add, create a dependency name. Just click create. So now you have the dependency map created here. So as you can see, we mostly have the Windows server, and the dependencies between the Windows server and the other server elements are mapped here. So this is how it looks in the UI. Let's talk about monitor groups. So we also have something called as monitor groups, which are a logical group of one or more monitors that provide a holistic view for your business environment. For example, the health of an online web application depends on various factors, such as the health of the application server running and the health of availability of the web server for accessing these web applications, the database server for storing and getting the required information as well. So these web applications and services can be grouped together and monitored as a single monitor group. So to create a monitor group, go to new monitor group. So here we have three types of monitor groups. One is the monitor group, and is the web application group, and we have design business service. Here we can go to monitor group, just add a group name, give a description. So you can assign the users and the owners for this particular monitor group. You can decide whether it's a normal monitor group or a web application monitor group. If it's a web application monitor group, you have different application components. You can select based on your requirement whether you need all of these application components, and just click create group. So here you will get all the dashboard details. So let me show you how it. And here you get the recent alarms, event summary, and the recent downtimes as well. So let's move on to the second topic of this series, which is measuring key performance metrics across your application infrastructure. So what happens when an issue arises? You don't understand where it is coming from. The cloud ops team blames the applications team, which blames the network team, and who in turn they can blame the DevOps or the app ops team. And the blame just keeps shifting here and there up between the teams. So what is the problem here? The problem is that we don't have cross-domain insights. We don't have a contextual correlation, and we don't get instant troubleshooting. So the problem is prone to be because of lack of unified visibility. So what do we need to get insights into? So how can we provide insights based on what the teams require? Like if, for example, what the DevOps teams require, or the InfraOps teams require, what the SecOps teams require, and what the NetOps teams require. So how do you tackle these challenges and understand where exactly the issue is? For that, we need visibility into what exactly constitutes an issue. So here, for example, we have the four types of components. One is the application component, operating system, network, and hardware. So here, for an application, the issue is mainly app slowness or unhandled exceptions. For an operating system, it's poor provisioning of server and virtual resources. For a network, it's due to excessive network utilization and error rates. And for a hardware, a issue is mostly a hardware error or an availability problem. Before we go in depth about what are the issues that you can resolve or what can be monitored in Applications Manager, I'd like to tell you about the agentless and the agent-based monitoring available in Applications Manager. So what is better when it comes to monitoring your IT infrastructure? Is it an agentless based monitoring or an agent-based monitoring? Is it better to install an agent on every server to monitor its performance, or should you go for an agentless approach? So there we get a dilemma. When to use agent-based monitoring? When you can't enable SNMP or WMI, when the credentials can't be shared, or when specific ports can't be opened. So when you choose an agentless monitoring, when you don't want third-party programs installed on your servers, it's advisable to go for an agentless approach. And when you don't want support of OS of any flavor, as well as custom servers that do not allow for installation of server agents, you go for an agentless server. So I would also like to let you know that we provide agent-based monitoring for Windows and Linux now. For this, we just need to go to the settings, data collection, manage agent, and deploy agent. Let me show you how it looks in the UI quickly. So you go to settings. Here you get manage agent under discovery and data collection. And you want to deploy a new agent. Go to deploy agent, select the OS which you want to deploy. Now you have to download the installer, which is provided here. The link is provided here. Run the installer, enter the credentials along with the hostname and SSL port. The device key is present here. You can just copy and paste it in the agent, and the host name as well as the port is present here. Then complete the installation and verify the installation to complete it. So this is how you add an installation, a server agent for Windows or Linux. So moving on, as we discussed, we'll look at the key parameters to focus in order to avoid an issue in various infrastructure elements. For example, let's go to application servers. So what are the key parameters that you need to focus on? One is the request throughput. We have threads, we have server response time, we have JVM heap usage, and connection details. Among these critical metrics for application servers, the JVM heap usage stands out. It acts as a vital gauge for identifying memory-intensive sections of your Java applications. By monitoring this metric, you can pinpoint memory hogs, detect memory leaks, and optimize the memory allocation. So Applications Manager empowers you to monitor the JVM heap usage effectively. By monitoring the heap usage, you can proactively manage your application's memory footprint, prevent memory-related issues, and ensure optimal performance. While JVM heap usage is critical, it's not the only metric for ensuring optimal server health. Similar to JVM heap usage, Applications Manager allows you to configure alerts for server response time and thread utilization. This proactive approach ensures that you're notified of potential issues before they impact users or application stability. Additionally, you can analyze the historical data to identify trends and patterns to enable better resource allocation and application optimization over time. So moving on to servers. When it comes to servers, here are the key performance metrics that you need to focus on. We have the system level performance metrics, we have server availability and uptime, and we have application level performance metrics. So when it comes to servers, we have something called as event logs. So monitoring these event logs can help you understand how the system is operating, and they can also give you insight into the health of the system. And in servers, we have something called as process and services. So monitoring the servers at process level tells you why the server is resource constrained and what's causing this issue. This clarity will help you detect when a specific process goes haywire, which deprives other processes of resources and brings down the performance of the server or the entire infrastructure. Without process monitoring, identifying the root cause that trigger these chain of events is close to impossible. Moving on to database servers, the key parameters to focus here are queries, database connections, backup and jobs and log statistics. But why do you need to monitor these metrics? When you monitor query performance, it becomes easy to identify queries that take too long to run. And you can also track the queries that are most frequently used in your database. And by monitoring the database connections, you can check how many database connections that you actually need and how many are running. By monitoring the backup and jobs, you can understand when the backup was last taken, and you can ensure that you receive notifications on time. By monitoring the log statistics, you can look out for log wait times and identify which transactions are blocked. So here, particularly the backup and jobs is a very important metric to monitor, because then you can create an alarm for when the last backup was taken, and if it's not taken on time, you can get notifications as well. So you can also monitor the session details to understand the users who are currently active, check the log statistics and buffer pool usage of the database server. So Applications Manager can pinpoint slow-running queries that are hindering the database performance. By identifying these queries, we can prioritize the optimization efforts and address the root causes of sluggish database operations. Let me show you how it looks like in the UI. Before I show you how it looks like in the UI, you will be getting a poll right now. So whether you need a demo or not, please answer the poll so that we can help you serve better. And now let's look at the metrics that you can monitor in Applications Manager. So here, let's take a look at the WebLogic server. As you can see, this is the WebLogic server. You get details about the response time, the availability, and attribute. And you also get memory pool details, garbage collection, etc. As you can see, we support 24 types of application servers. We get Java Runtime, JBoss server, Jetty server, Oracle Application Server, Tomcat server, and WebCS server. So let me show you another example. This is the Tomcat server's UI. As you can see, we get details about the availability, the server response time, server performance, thread usage, the class loading, the response summary, request summary, etc. Additionally, you get in-depth details about the memory here, the thread usage here, the thread pool utilization, the busy threads, both in a tabular and in a graphical format. You get to view the JDBC details here with the active connections, idle connections. And you get to view the web details, the request statistics, processing times. And you get details about the web applications and servlets as well. So this is about application servers. Moving on to database servers, let me show you what you can monitor in a MS SQL database. As you can see, we support a lot of database types. Among them, we have MS SQL, MySQL, PostgreSQL, Oracle database, etc. These are the popular ones that I showed you. And now here in the MS SQL database, you get an overview section of all the details present here. Basically, this is just the overview or a summary of all the metrics that are present in this database. To get in-depth details, we have to check the individual tabs. So under the performance tab, you get details about the queries. So here you can sort the queries by CPU. So by clicking on the top queries by CPU, you get the the details about the queries that are hogging up the CPU with respect to average CPU time, total CPU time, and you also get this query details based on which you can configure alarms as well. And you can take an informed decision about whether you want to stop this particular query from running because it's hogging the CPU or not as well. And you can sort it by IO as well, CLR, top waits by waiting tasks, and most importantly, you can identify the top slow running queries here and the frequently executed one, like I mentioned, the most block queries, the top queries by lowest plan need reuse, the cost of missing indexes, top components by memory usage, etc. And under the database tab, you'll be able to view the database details such as the size of the data file and the log file, and you can configure alerts and create reports on it as well. And you get details about the connections, SQL statistics, the details related to the connection, and the host details. In addition to that, you can also monitor the session details where you can identify whether the particular session is running or sleeping and which program it's running on, the memory usage of that particular session, the CPU time it takes, IO, whether it's blocked or not, and the wait time. And as for the jobs, you get the job details where you get the current execution status, the last run status, the run date and time, job time, etc. And for backup and restore, which is the most important, you get backup details such as when it was last backed up. The data is not available right now, but you get details about when it was last backed up, and you also get the details about when it was last restored as well. Under replication, we get replication status, replication agents, etc. And under users, you get details about the users who are accessing this particular database, the status of that particular access, the login type, the default database, and the creation time. And you get configuration details as well. Under servers, let me show you. These are the servers that you can monitor with Applications Manager. There are around 42 servers you can, 42 monitors under this particular tab. So you can monitor all of these servers. And let me show you how it looks for Windows. So under Windows, we have a few key metrics that you need to monitor no matter what. And those key metrics are metrics that are related to CPU, memory, hardware, and event logs. So here the overview tab gives you a general summary of all the metrics present. The CPU tells you how much resource or the CPU has been utilized by CPU cores. So the breakup of utilization by CPU cores. And under the network, you get the network interface, the details about the network adapter, the firewall details, etc. And as for the event log, you get details about recent events in the event log, where you can see whether it's a type of error or if it's another event, the source of the event, the username, and the description here. And you get details about the nodes, clusters, and other nodes in the clusters as well. You get details about the scheduled task. If you have any print queue, it comes up here as well. So moving on to next topic, how to leverage AI and machine learning to detect anomalies and troubleshoot the issues quickly in Applications Manager. So this is a familiar scenario. An IT environment generates a flurry of alerts when an issue strikes. Unfortunately, the sheer volume of these alerts can overwhelm the IT staff, which leads to a phenomenon known as the alert fatigue. In such situations, critical alerts might get overlooked by the level 1 support or the network operations system center team. Additionally, the point of contact personnel might lack sufficient context to effectively assess the situation. So imagine this scenario. You have an MS SQL server that relies on backup every 12 hours to ensure data protection. Unfortunately, due to an unforeseen issue or a circumstance, the backup process fails silently, which leaves your data vulnerable for the past 24 hours. And manually sifting through logs and alerts to identify such missed backups can be time-consuming and error-prone. So Applications Manager empowers you to automate the response to these missed backups, which eliminates the risk of human error and ensures data safety. Here's how it works. So it gives you automated monitoring. Applications Manager continuously monitors your server, the database server, which keeps a watchful eye on the backup process, which I showed you before in the UI. And you can create a custom script for the action that associates this alarm with a specific SQL job action. And you can trigger it when the backup age on the server exceeds a predefined threshold. And by automating these recovery steps, or by using a custom script or using an SQL job action, you can reduce the manual intervention. And also you can escalate this particular alert through a notification email or SMS to the IT staff, which can help them react easily and more sooner than it affects the end users. The automation helps you reduce the risk of data loss, improve efficiency, enhance reliability, and enables faster recovery. Another important area where machine learning is used is threshold profiles. Applications Manager currently supports static, adaptive, and anomaly threshold profiles. For example, if you have a Tomcat server where you want to monitor memory utilization, instead of configuring a static threshold, you can choose an adaptive one when the current memory utilization deviates from the usual pattern. And then you will get an alert when the threshold is being violated. So I'll show you how you can access the threshold profiles in the UI. So here we have something called the threshold profile. And you can create a new threshold profile here. Like I mentioned, we have the threshold profile, adaptive profile, and an anomaly profile. So under threshold profile, create a name, for example, CPU. And you can mention the severity if the monitored value is lesser than or greater than the threshold limit of whichever numerical value. And by clicking on Show Advanced Options, you can add a message, you can use polls, and you can also specify the warning severity and clear severity. And you can also apply these thresholds based on business hours if you want to. Creating this threshold profile, you will be able to view it in the threshold profiles here. And in order to associate it with the threshold, with a particular alarm, you go to alarms and then you can configure it and associate these actions. So moving on to anomaly profile, we have, in threshold profile, we also have something called adaptive profile. Here, we have two types of adaptive threshold profiles. One is the automatic and another one is the manual. So here, create the threshold profile name, and you can give the critical severity if the deviation percentage is greater than the threshold limit of the said numerical value, or if it's less than or less than equal to or not equal to. So you can basically decide on what the critical severity here is. And here you can give the warning and the clear severity as well. Under manual adaptive threshold profile, you can base it on baseline values or a custom expression. So if you want to set the baseline values, you can select a fixed baseline based on previous previous week's report data, or if you have a week that was performing exceptionally well and you want to compare it with that week's data, you can do so as well by clicking on any one of these weeks here. And if you want to check or specify the baseline as percentage, you can do so by checking this box. Here you can give the critical severity if the monitored value is less than the threshold limit of the said numerical value. And you can specify the same for warning and clear as well, after which you can create this particular adaptive profile. And for anomaly profiles, you can create a profile which detects anomaly based on baseline values, which is basically similar to adaptive profiles. You can fix a baseline based on week 1 of a particular month's report data, or you can create a moving baseline based on the previous week's report data. And then when you want to specify an anomaly is where you specify it here. If the values exceed or crosses the upper limit of 20%, you get a critical alarm. If the lower limit crosses 30%, you get a warning alarm. And this comparison can be made with the last hour directly or based on the corresponding difference with the previous hour as well, and create quick anomaly profile. And you can associate this anomaly or adaptive or normal threshold profiles with all the metrics by going to the metric and associating it with them. So Applications Manager offers a comprehensive suite of reporting functionalities. We have support for performance report for over 100+ report types. And if you want to identify under or oversized servers or an idle service based on memory and disk utilization, we can make use of the capacity planning reports. And with the help of machine learning, we have something called as forecast reports, which predicts the the usage of servers and resources for up to 3 years into the future. So basically, if you want to optimize resource allocation within your organization or within your IT infrastructure, we can make use of the capacity planning and forecast reports here. And here are some of the report types we support. One is the health and availability report, which gives you the health and availability of that particular monitor along with the error message, etc. And then we have the downtime summary report, which gives you the summary of downtime or when that particular monitor has been available with the details about the unmanaged and scheduled discovery and the downtime and uptime summary as well. We also have something called a trend analysis report, which gives you a trend of that particular metric. For example, here you can see swap memory utilization, system time and percentage, disk free space, and you get a graphical representation of how the trend is. We also have something called the historical report, which provides a detailed history of that particular attribute or the metric of a monitor. You can generate this historical trend across business hours for a particular attribute. This provides you with an understanding about the amount of resources that has been utilized by the particular attribute over a period of time, whether it is a week or a month or a year. You also have hour of the day report, which is a sample hour of the day report that is shown here. It generates an hour's average for a particular time period, say a week or a month or a year for that particular attribute. It's basically just an hourly average report. And this report helps you visualize the various bottlenecks that appear during a particular time period. It allows you to plan the future impact of the bottleneck on this attribute or resource. Then we have something called the inventory report, which gives you all the details about all the elements, IT infrastructure elements, or the monitors that are present in your IT infrastructure, basically an inventory of sorts. And here you can plan the infrastructure capacity with utilization reports. Basically what we offer and what I told you about in the beginning, the capacity planning report. Here you can identify whether that particular server is underutilized, overutilized, or idle. So what are overutilized servers? So imagine a server with a powerful 4 GB memory configuration, but it only runs a single application. This leaves you with most of its capabilities being underutilized. And this scenario signifies an oversized server. Here, and how do you identify these oversized servers? Applications Manager helps you pinpoint these servers by analyzing memory and CPU utilization parameters. This screenshot here is an example of an undersized server. If it were oversized, you would get details about the CPU utilization and memory utilization here. And here, let me tell you what undersized servers are. So on the other hand, undersized servers occur when the resource allocation falls short of the actual application needs. So for example, if you have an 8 GB memory, but it's running 4 applications. So whenever the users access this server, the CPU usage is constantly above 90% and can even reach 100%. So here, in that case, it would be marked as yes undersized server, and it would show you which parameter, whether it's the CPU, memory, or disk that is being overutilized. Here, in this example, we have the memory utilization reaching 100%. So Applications Manager, like I said, it helps you identify these servers alongside by monitoring the CPU, memory, and disk utilization. Next is forecast reports. Applications Manager goes beyond traditional monitoring by offering these forecast reports. These reports leverage historical data to prevent future trends for metrics like server disk utilization, database files, etc. This proactive approach empowers you with the valuable insights for capacity planning. Let's say you want to predict the disk utilization for a specific server in June 2026. So since Applications Manager can predict or forecast the growth trends for up to 3 years into the future, you can just view it by clicking on the time period here. So if you want to view it into 2 months into the future, you can click on 2 months and you will be able to see how much growth of the usage is. And for example, if it's around July, then we can click on 1 year, to July of 2026. For July of 2027, you can click on 2 years and it will show you the growth trend. So by using this information, you can either allocate more resources or allocate lesser resources if the trend is shown to be decreasing. So that is it about reports. Moving on to dashboards and widgets. We have 3 kinds of dashboards. One is the default dashboard, and the other one is the business view, and the third one is the availability dashboard. So with the business dashboards, you can quickly configure your business metrics like customer wins, revenue, etc. It helps the manager to align IT with the business needs. So we also have some smart widgets, such as performance widgets. We have health and availability widgets. We have a heat map widget. We have a server uptime widget. We have alarm summary widgets. We have monitor error status widgets, business view widgets, utility widgets, etc. Let me show you how it looks like in the UI. So under the dashboard, you have the default dashboard. We have the application business view dashboard. For example, this is the dashboard for application banking application. So based on this, you can add all these widgets to that particular dashboard. And if you have any other requirements as well, you can create a business view for the same. So like I mentioned about the widgets, we have the heat map widgets. We have health availability and alarm summary widget. We have the performance metric widget, both in 2 types of charts. And we have the infrastructure snapshot, and we have recent 10 alarms, top end monitors, monitor status, attributes, alarm widget, monitor groups, tabular data, server uptime, the dependency map, the topology map, the world map, etc. So this is it about the widgets and dashboards. So finally, we come to the last topic of today's session, how to achieve more out of Applications Manager with built-in integration. So with Applications Manager, there are two types of integrations, like direct integrations and indirect integrations. With direct integrations, you can just go to our UI and add it as an integration. With indirect integration, we can use webhooks and integrate with other third-party applications. So here we have integration with Prometheus, ServiceNow, and Slack. And also we integrate with other ManageEngine products such as Alarms One, Analytics Plus, and Service Desk Plus. So here, what are the advantages of a built-in integration? You get end-to-end visibility. So if a ticket is created for an event, it will have all the data in a single console, and it will also help us prevent an SLA breach. It can reduce the bottlenecks. It can give you performance insights. It is more efficient when it comes to reporting. And like I said, you can avoid an SLA breach. Let me tell you about the Service Desk Plus integration or the ServiceNow integration. So here you can automatically discover the IT components of your configuration management database of Service Desk Plus and then create dependencies amongst them in Applications Manager. Here you can track the configuration items in your IT infrastructure, map the relationships, and predict the impact of these said CIs on your business if any modification is made. So you also get faster troubleshooting with instant ticket logging and action. So you can automate the process of categorizing, prioritizing, and assigning tickets to technicians in Service Desk Plus from Applications Manager. So you create a ticket, track the change on the status of the ticket and all its updates until it's finally resolved. In Applications Manager, when a predefined condition for a particular monitor violates its threshold value, an alarm is instantly generated and consequently a configured action is executed. With everything automated, you forget about tracking your tickets manually all the time. So you can ensure that no ticket is unattended ever. You can create new or reopen a ticket when an alarm is raised for a previously closed ticket. You can close a ticket or update notes in Service Desk Plus when an alarm is cleared. You can update a ticket when there's a status change in alarms, or you can view request details from the Applications Manager console. All of these actions are automated. And with the Microsoft Teams integration, you can integrate it with the Graph API or the MS Teams connector. With this integration in place, you will get real-time updates regarding any application issues in your team channel. And with the Analytics Plus integration, Analytics Plus is our in-house reporting tool where you can access the ROI using infrastructure-specific dashboards, and you can fast-track report generation with augmented analytics, etc. It basically gives you advanced analytics of all the trends or all the reports that are present in Applications Manager. And we also have Prometheus integration, so wherein you can import all the Tomcat servers or OpenShift servers at one go. And finally, I would also like to let you know that we also have mobile apps for Android and iPhone, where you can get an overview of all the monitors, monitor groups, and subgroups with availability and status directly on your phone. And with this application, you get critical alerts on the go. So you don't ever have to have your laptop at all times. When you log off, you get an alert directly to your phone, even without an escalation through an SMS or an email. So I'll show you how this particular integration or looks like in the UI. So in order to integrate, you go to Settings. Under Settings, you have integrations here. So as I mentioned, we have third-party integrations with Site 24/7, Prometheus, ServiceNow, Alarms One, Service Desk Plus Cloud, Slack, Service Desk Plus MSP, and on-premise, Op Manager, PAM 360, etc. So in order to add a service desk class, here you can specify the server name, the port number, REST API key, the protocol, whether it's HTTP or SSL. So mail notification for connectivity failure. You can log tickets, and you can also sync configuration items. And after you've given all the right details, you can test the connection and save it. And based on this, you get to perform automated actions on service help desk. As for the Prometheus integration, you just click on Add button here, specify the general specifications such as the display name, port, the mode of data collection, whether it's an exposed Prometheus API or CURL through SSH. You give the details about the Prometheus server here, along with the Prometheus API port, endpoint, the protocol, authentication method, whether it's a basic authentication, no authentication, or service account token, discovery specifications. This you can monitor, you can get all the, you can import all these monitors here. Like I mentioned, Tomcat, OpenShift, Nginx, and Kubernetes. You have discovery options where you can pause discovery, monitor, and discover but do not monitor, but only for certain instances also you can monitor. And action on date monitor if the data is not available is also given here. Save this and it will automatically get the details about the monitors for the monitor types that are present here. So that is it about integrations and mobile apps for Applications Manager. So about the editions that are available in Applications Manager, we have three types of edition. One is the free edition, which supports up to few monitors, like around 5 monitors with a few restrictions. You won't get all the features that are present in a professional or an enterprise model, and it's free forever. For a professional edition, it is ideal for medium to small enterprises which are looking to monitor up to 500 applications or servers or monitors based on load. And we also have enterprise edition for large enterprises which are looking to monitor above 500 monitors or applications or servers. It scales up to 10,000 monitors with the help of a distributed setup. So if you have any doubts regarding this, or if you want to contact our eval team, you can do so by sending us a mail at eval-itom@manageengine.com. Our support people will be able to help you with this, and they would support you with whatever information that you want. So let's go through a quick recap. Before we go through a quick recap, you will see a few questions being asked to you in your monitor or on your screen. Please take your time to answer the questions so that we may be able to serve you better in the upcoming sessions as well. So let's take a quick recap. So we had like 4 parts in this particular session. And in part 1, we saw how you can auto-discover components and dependencies across your entire application stack or the entire IT stack with the help of our application discovery and dependency mapping feature. In part 2, we saw how you can measure key performance metrics across your application infrastructure. What are the key performance metrics in your application server, database server, and operating system server as well, and how it looks in the UI of Applications Manager. In part 3, we saw how you can utilize AI and machine learning to detect anomalies, analyze performance trends, and plan capacity. And in part 4, we saw how you can leverage the most out of Applications Manager's integrations as well. Thank you for tuning into this session. It has been wonderful presenting the first topic to you.